Hello, it's Science Mr. Robertson here again, another video time. And this time it's a topic of cleaning us. Because we're quite dirty. And, I'm not going to be like, hey, dirt, oh that's terrible, you need to get it off straight away. No. Absolutely not true, in fact. You actually find there's a lot of research in that humans nowadays do actually spend too much time cleaning. We need to be clean so that we don't get as many bacteria into us as we should, but we shouldn't panic about cleaning. It's very important to have a distinction there. But it is good to clean, nevertheless. Now, if I'm dirty, if I've got a bit of dirt all over me and all the rest of it, usually most of that dirt is made up of fats. Fats, people have oily skin, especially teenagers. Hormone imbalances mean spotty faces are quite common. It's a build-up of fats, basically lots of fats that get into the skin. And if there's too much, we want to clean it off, okay? Now, how we can do that? Well, we can add water. Put your hand in the water, give them a rinse. Lots of things will come off in water. Fats don't. The fats would stay, actually. You may get some bits of dirt and soil and things off your hands, but the fats would remain. And this is where a bit of chemistry comes in, okay? What we say that these fats, they're a type of molecule which is called a non-polarized. What that means is non-polarized. If you think about the Earth, we have a north and a south pole. So it's polarized. There's a north pole and a south pole. There are positive and negative parts to it. If something, I'll do that bigger, non-polarized. Basically, those fats that are non-polarized, they are made of molecules which are not positive or negative sections. Of course there'll be protons and there'll be electrons scattered around, but there is not one side positive and one side negative. That's not how that works. Water is polarized. You can see that when you actually look at H2O. We call water the Mickey Mouse molecule. You see that? You can, good. You have the two hydrogens and the oxygen in the middle. And remember, you have to share electrons here. So it moves the electrons towards the oxygen much more, making this minus and the hydrogen positive. It is therefore polarized, imbalanced. So what I have here, positive and negative, it's a polarized molecule. The polarized meaning here, different parts of the molecule are charged. Now, that means water, all of this science here, that means water is no good for actually cleaning us and getting the dirt out of us. So, I have those fats, and what I need to do is put something in the water. What I need to put in that water are chemicals we call detergents, or in Swedish I can talk about tändstickor. Those are the kind of molecules that will actually help me clean, because they are actually going to be polarized too. But what you actually have is a little bit of a difference with that molecule. One of those going into water, remember, the water is polarized and this is polarized. One side of this loves water. One side of it loves water. One side loves fats. You see where this is going now? So I have fats and water, don't mix. When I put in the detergents, so the soap, for example, into the water, what happens is the soap molecules actually get in, and one half will go, ooh, water, yay! And the other half will go, ooh, fats, yay! And the molecule actually stretches out to go, ooh, I like the water, ooh, I like the fats, and it's just like this shape here. And you actually get these molecules here. Can you see over here? Yes, you can. You actually get these molecules being quite long chains like this here in their shape. Usually we draw them with a head like that. And that there is going to be the polarized head. The polarized section, which loves water. Now what happens if I have a bit of fat on my skin? Here's my fat. Can you still see this? Yes, you can. Good. Here's my fat over here. What happens? This bit loves fat, that little tail bit. So this tail bit goes to the fat. And another tail goes to the fat. And another tail, and another tail, and another tail. And it continues until the entire bit of fat is covered by these little squiggles here. And the other side, of course, loves the water with the heads on. And they're happy, they're in the water. What happens, you go all the way around this here, and the soap, all the soap molecules have gone around the fat. That fat is now lifted off the skin, and you can wash it away. That's how the soaps work. You go in, the fat-loving bits get around the fat, and it can just slide it off as it goes through the water. That's how we keep ourselves clean. Also, if you've actually noticed, what this actually does is it stops the water molecules from really touching each other, because this here loves the water even more than the water loves water. Experiment at home. Take your hands and rub them like this. Do the same in water, okay? So get your hands wet in water and do this. Should be easier, should be less friction, should be smoother. The water goes into the gaps, makes it smooth. Do the same and do it with soapy water. It should be even more smooth, because the little bits of